Okay, good morning everyone. Welcome back to the linear regression analysis lecture. Before we start the lecture today, I just want to remind you about the the scheme or the design of our lecture. So if you may remember, we have this file, okay, what we need to discuss every week. And up to now we have finished on the multiple regression analysis and we've done the mid-exam, so we should be continuing with the actually other linear models. We already discussed some of it before the exam, but we will just have a look a little bit more on this topic later, and we will be also discussing about the test for comparing nested models and stepwise regression, but we will see how we go for today. Okay, but before proceeding to those topics, I think that it will be nice for us to discuss a little bit about your mid-exam. Okay, so we will have a go to the exam. Okay, so this is the questions for our exam last week. Actually, this question is taken from this book, but from the previous I think that the 5th edition of this book. Unfortunately, I don't have the ebook for the 5th edition, so we'll just have a look at the questions directly. Okay, question number 1, it was 50 points out of 100 points. Okay, so based on the questions, we have the data on 1990 census in the United States about the number of homeless people. That would be our response variable or the Y variable, and it is thought that this number of homeless people can be explained by 16 independent variables. What are those 16 variables? Those are the ones that given in this table. Okay, so then because of that idea, so we try to fit the multiple linear regression model. Sorry, why is it okay, so we fit that model. Okay, so we have that beta naught plus beta 1 x1 up to beta 16 x16. The first question is to interpret the beta estimate for the independent variable, rental price. So then I just copied the table down there and paste it here, and then add one more column here just to make it easier for you. So which one is the x1, which one is the x2, and so on. So in here, and I also put okay the beta estimate, the symbol beside the beta estimate, so the coefficient that is associated with the intercept is the beta naught, and the coefficient associated with x1 is the beta 1. That's how we relate these symbols with the name of the variables here. So based on this output, we can get that according to this model, that beta naught plus beta 1 x1 plus beta 2 x2 and so on, we get the fitted regression equation in here. So then y cap is 307.54 plus 2.87 times rental price, that is the 10% of the percentile of the rental price, and so on all the way down there up to the 16th variable, that is we got beta 16 cap is 1.22. So the contribution of the 1984 population is 1.22, and we write it down in our regression equation like this. Okay, So the interpretation of the beta estimate for the rental price is here we have 2.87, and because our y is the the number of homeless people, so we can see this according to the sign that is positive. We can say that as the rental price increases, then the number of homeless people is also increasing. That is, and the number of increasing is the 2.87 for each unit increase in the rental price. So we can write something like this. But then put in mind that when we evaluate the effect of the rental price, then that number 2.87 is the increase in y as the rental price increased by 1 unit, holding all other variables constant, all the other conditions are the same. So that's all what we need to know from question A. And the next question, does the hypothesis that the incidence of homelessness decreases as employment growth increases? So we will look at the employment growth here. Where is the employment growth? Okay, so here we have the fourth variable is the employment growth. So that is our x4. Okay, and then we have that the estimated beta is minus 859.09. So then from this, okay, from this statement, number of homelessness decreases as employment growth increases. It means that we are testing the hypothesis of one-tailed hypothesis testing, and decreases means that beta 4 is less than 0. So we can write our null hypothesis either something like this: beta 4 equals 0 versus the alternative beta 4 less than 0, or like the second one here. Actually they are just the same, because basically what we are testing is that we only can test the value where beta 4 equals 0. Okay, so then based on this hypothesis, then we have to test statistics is that follow the t distribution with the degrees of freedom of n minus the number of parameters to be estimated. And because here we have 16 variables here, so we have 16 plus 1 parameters, because we have here beta naught. So then we have 17 variables to be estimated. That's why the degrees of freedom for the statistics, the test statistic is that the sample size minus 17, and then from the question it is given that the sample size is 50, as you can see from here. Where is it? Okay, so data on the number of homeless per 100,000 population in 50 metropolitan areas. So one observation is one area, and we have 50 areas, that's why we have 50 observations in here. So then we have this from this table, then it is given the t value is minus 2.71. So then it's no use of doing this kind of calculation. Yes, we are given that beta 1 hat, but then we are not given the information about the standard deviation or the sum square of the deviation of x, or symbolized by s as xx. So we just make use the value that's given in the table. That is the t value minus 2.71. That's the number that's addressed by this formula. And then we compare this t value with the t distribution from with 33 degrees of freedom, and then we can just use the online t calculator. Okay, so I just go here actually, and then just type t calculator, and then you can choose whatever given in here. So let's say I choose this one, and then okay, So here degrees of freedom is 33, and then we are testing it at the significant level of significance level of 0.05, and then we have this value. Okay, for the right-tailed is 1.69, and then for two-tailed is plus minus 2.03. Because here, because we have one tail hypothesis, of course, then see, of course we will take that one tail test, and then in here our hypothesis is the left tail test. So according to this result, that is 1.69, but it is the right tail, so we will take the left tail, because we are testing the one tail but on the left tail hypothesis because of beta less than 0, and because the t distribution is a symmetric distribution, that's why we know that for the left tail it should be like minus 1.69. So in here we just need to compare the value that we have from our calculation, minus 2.7 with the minus 1.69, and then because the calculated t value is less than minus 1.69, then the null hypothesis is rejected. So we can say that it is evident from the data that the incidence of homelessness decreases as employment growth increases, and we can say it's statistically significant at a significance level of 0.5.